Let's see a graph problem from the LeetCode. It's a medium level problem. So let's try to understand first, and then we'll try to understand the approach to solve. So this problem is saying we have graph given. So there is a data structure called node, and which has the value and then neighbors. So if you see the one, so there is a one node, one, and it has neighbors 2 and 4. In the similar way, for the 2 there is a neighbor 1 and 3, and we want to clone this. So when we want to clone, then we have to create exactly 1, and then we need 2 new node again, and for this 2 new node we just need we need to fill exactly this value 2 and the 4 in a new node. And if you see this problem, this is a very recursive in a nature, because we call 1, and for the 1, like let's say we create the node 1, and for 1 we need 2 neighbors. Then for the 2, again we create for these 2 1 and 3, 1 already exists. For the 3, 2 and 4. So that's a recursive in a nature. And when we solve this, how we are actually going to solve is first we'll create 1, and then we'll create the new node and put that in a map. So in a map we'll put the old value 1 and a new value 1, and then for the 1 we want 2 neighbors. So this is a new node, and let's say this 1 doesn't have any information about 2 and 4. Then for this 1 we iterate through these neighbors, and we'll get the 2 and 4. We'll get the 2 and 4. So for the new node, we just put 2 and 4 over there. But when we do this, when we try to put 2 and 4, again we call the recursively, and we want to fill the neighbors of this 2. So we'll take the bottom up approach. So we'll go to the bottom, keep going, check that, okay, for the 2, again, what is the neighbor for 2, 1 and 3, for these 2, 1 and 3. Again we'll check what is the neighbor for 3. So 3 is a 2 and 4. Or for the 4 we'll say 1 and 3. But if you keep going recursively, then again it will never stop. So we need to find out the best condition. So the best condition is, for this 4, we'll go to the bottom, and again eventually we know that, okay, for this 4 we have already created a node 1 and 3, and so that's the node just we want to associate there. So let's try to understand this through one small example, and then we'll write the code. Code is very simple when you go to the recursive approach. So I took this example 1 2 4 3, and for this one I created a new node, and for this new node I want the neighbors 2 and the 4, and I put that in a map. So come to this place 2, and again for the 2 I create this new node, and for this new node again I want to have these 2 neighbors, this 1 and the 3. So if you see 3 and 1 here, again from the 3 I'll just keep going in a bottom, just keep calling the recursively function, and for the 3 I need the 4 and 2, 3 4 and 2, and for the 4 again I need 1 and 3. So here I stop when I see the 1 and 3. 1 and 3 and 1 have already been created, so the node is already there in a map. So simply what I do for the 4, when I call iteration, it will call 2 times for 4. So 1 and 3, 1 and 3, and it check that in this node is already in a map. So we'll get that and just link to the new node. So and here we stop the recursion, and in this way 2 also does the same way. Eventually 3 neighbors will filled, and then these 2 nodes neighbor will be filled, and then will come for here 1, and the 1 neighbors will get filled. So that's the logic we are implementing, and the logic is very simple. So here first I just check if the node is nil, then return nil. Otherwise I created just one map where old node is key and the new node will be the value, and I'm passing that in a clone graph helper function node and this map, and then we need to, and there are very few lines of code. So just let me complete this. and this will return a star node, and this type is also a star node, and for this map and the key is star node and the value is star node. So that's the function. Let's create a new node. So first I'll create the new node, and the new node is node, and it's the value I want the value of the new node from the old node. So I'll take the value from old node. So I for this one, I created a new node and I put this value 1 here. Just I need the next thing, the children. So for this, in order to get the children, then for 1 I need a loop here. So I'll run the loop, and in this way I'll get the 2 and 4, and in this way I'll fill this neighbor 2 and 4. So I'll call here this let's say n and range, and that's the old node is node.neighbors. So I'll get 2 and a 4, and for the 2 and 4 I want to create the new node and fill that to the new node neighbors. So I'll put a new node dot neighbors is equal to append new node dot neighbors, and here I want to when I get 2 and 4 one by one, then again for the 2 I'll just go and call this function recursively. So we'll go to the bottom and the solution will be filled from the bottom. So clone graph, where I pass this n, and then I can pass our map m, and the new node return new node. Okay, so in this way, keep calling. So we'll get the 2 again, 2 will call the 3 and 1 again. So we need somewhere to stop. So let's check that. Okay, that is already in a map. So when we create a new node, just put that also in a map. So old is node, that's the key, and the value is a new node. I'll put that in a map, and I will check here if you can just say n1 okay, and I'll check in a map, that's node, and if okay, return n1. So that's the solution. So let me run this and check for the syntax error. Accepted. That's nice. It's got accepted first time. Okay, so we'll see again, we'll see the Java solutions also. So I've already tried that. It's the same logic. If the node is null, then return null, otherwise create the map and then clone graph helper, and we create the new node and we'll fill the value of the new node, and for the new node you want to fill the neighbors. They will iterate the old node, and then we'll get the neighbors of the old node, and we'll call this recursively, go recursively, and check that the some point it will find that in a map, so we'll return that node from there itself, and then from the bottom we fill the neighbors of each node, and then we'll come to the top. So that's all. Thank you.